Hello and welcome, everyone. My name is John Morrow. I'm a professor of materials science and engineering at Penn State University and co-author of the book Fundamentals of Inorganic Glasses, third edition, together with my advisor here, Professor Arun K. Varshnaya, who is now retired from Alfred University. Welcome to this first lecture in a course on Introduction to Glass Science. What we'll be doing over the course of the next few dozen lectures or so is covering some basic topics in the applications of glass, basic glass physics, chemistry, structure of glass and how it influences its properties, as well as glass technology. How do we melt glass? How do we form it into different shapes? And what I'd like to do today is actually start at the very end of this book. So the very last chapter of this book is about applications of glass and kind of giving us a bit of a history about all the important applications of glass that have made modern society what it is today, as well as providing some forward-looking thoughts about new applications in glass that will be important for humanity going into the future. So with that, let me share my screen and let me start this lecture here. This is lecture one of our course on Introduction to Glass Science. And starting here at the very last chapter, chapter 23 in the book. And I hope you will enjoy this lecture. And if you have any questions, feel free to put them down in the comments in the chat, and I will get back to you as soon as I can. So with that, let's get started. Now, the history of humanity is often defined in terms of the materials that have made the biggest impact on human engineering and culture at that time, whether it's the Stone Age or the Bronze Age or the Iron Age. Those materials have had a profound impact on how humans create tools, how humans are able to grow society and develop it further. And one of the most important materials that's often overlooked because we look through it rather than looking at it is, of course, glass itself. And this article, which was published a few years ago in the Atlantic Monthly Magazine, is titled Humankind's Most Important Material. Glass has changed the world like no other substance, but people usually overlook it. And they are making the case that we are actually living in the glass age now because of all of the various important contributions that glass has made to modern society, which we're going to cover today. And more recently, this is the cover of National Geographic from February of 2024. And this concept of the glass age actually made the cover. So this is covering how cutting edge technology is helping this ancient material reshape our future. And it's true that the history of glass is thousands of years. And so many people have this misconception that it is, some sort of antique material, something of the old days. But, the reality is not only does it have this very long, important history, it is at the cutting edge of materials physics and chemistry. And I do believe we are still just at the beginning of seeing how glass is going to impact society. So, what are some of the ways that glass has been a key enabler for modern civilization and also provided some of the tools for scientific discovery and enabling breakthroughs in other fields? One of the most common examples of the importance of glass is something that we experience every day, but really take for granted, and that is glass windows in architecture. So glass windows in our homes, in our office buildings. Enable the natural sunlight to come into our homes. They enable us to see outside while also protecting us from the harsh environment. So protecting us from rain and snow or hail from the outside, providing both mechanical protection as well as chemical corrosion resistance and the optical transparency that's needed to see outside. And they're providing good thermally insulating behavior to make sure that we can maintain the temperature difference between the inside of the building and the outside of the building. So in the summertime, we want to keep the indoors cooler compared to the outside. And of course, in the winter, we want to keep it warmer compared to the outside. And glass, even though it's such a ubiquitous common material, it provides all of these properties. It provides the corrosion resistance, the optical transparency, the thermal insulation, the high mechanical strength, all of these properties that are necessary to have a fully functioning window. Then there's the glasses that we look through, the spectacles that go back a few centuries. I couldn't imagine living through life, as someone who's nearsighted and not being able to see the world in focus. And this is something that has been life-changing for billions of people at this point. The ability to, change the focal point of what we see to be able to correct our vision and have fully functioning lives despite either being nearsighted or farsighted. And speaking of glass lenses were also transformational for the field of astronomy. So rather than just looking at the stars and looking at galaxies with our naked eye, using glass lenses, this enabled telescopes, and this enabled much more detailed study of astronomy, the discovery of new planets, new galaxies, and really, it opened up the entire field of astronomy. So this is an example of glass being really instrumental in the development of an entirely different field of study. And likewise, glass lenses have been critical for the development of microscopes. So optical microscopes would not exist without glass lenses, and this enabled the entire field of microbiology. So the discovery of the existence of microorganisms like bacteria, the existence of viruses, the nature of the origin of diseases, how diseases spread, and the whole field, not only of microbiology, but also epidemiology. All of this goes back originally to the optical microscope, which was made possible by glass technology. And then there's glass that is used as packaging. So if we go to the supermarket, you'll see glass packaging for juices and other beverages, for foods. One of the things that you'll note is that juices that are stored in glass packaging do not have to be refrigerated because the glass packaging provides better containment compared to, say, plastic packaging, where those beverages need to be stored in the refrigerated section. So glass is known for its high chemical durability, the ability to see inside, to see what the product looks like, and its high mechanical strength and the high resistance to permeation of gases or other things that could degrade the quality of the product inside. This particular container is not for food or beverage packaging. This is actually for pharmaceutical packaging. Glass packaging has been critical for the storage of medicines and vaccines. And there it's absolutely critical that the packaging not interact with the medicine or the vaccine that's being stored. And we have to be able to store that safely for at least 20 years or so, and also provide the mechanical protection that's needed, because if there's any crack in the glass at all, that crack could provide a pathway for bacteria or other types of contamination. So glass packaging has been critical not just for the food industry, but also for the entire field of medicine. Right now, you're watching this video over the internet, and all of the signal that you're receiving is being transmitted over very thin strands of optical fiber. This optical fiber was invented back at Corning Glass Works in 1970, and each strand of glass here is about the same thickness as a human hair. It's about 125 microns thick, and it's able to transmit signals of light over hundreds of kilometers. And this has been critical for the development of the internet, because this is what allows signals to transmit literally at the speed of light across the world, and sending extremely high bandwidths at different wavelengths. And this is what has brought humanity into the information age. So this is all sort of behind the scenes here of the internet. These cables are buried underground. They're going across the floor of the ocean. They are connecting the entire world. And this was, critical for us to be able to access all of this information that we have accessible to us today through the internet. And glass is critical not just for transmitting the information, but also displaying that information, whether it's the old cathode ray tube televisions or the new flat panel displays. Glass has been critical for this display of information. Here, this shows a large TV, but the same technology is used on computer monitors, laptop monitors, tablets, smartphones, and advances in glass technology have been critical to enable higher resolution displays with better color fidelity and longer lifetimes. And speaking of smartphones, glass technology has been critical for the development of smartphones. These are, actually really high-performing computers that are small enough to carry around in our pockets. And the glass is here not just to enable the display, but there's another piece of glass on the cover of the phones that provides the mechanical protection and scratch resistance that's necessary. And to me, one of the most interesting things about smartphones is that glass is not just something that we look through to see what's on the screen. It's actually the primary medium by which we interact with this computer. It's by touching the screen. And so the glass literally becomes the interface now between us and the computer. And finally, there's glass for transportation, whether it's trains or planes or automobiles. We need to be able to see out of our vehicles to see where we're going to drive them, while at the same time providing the mechanical and chemical protection that we need against anything that might come at us from the environment. So glass has been critical for the development of modern transportation systems as well. So here you see, architecture, you see communication theory, and communication systems, the display of information, medicine, agriculture, transportation, optics, all of these fields have been enabled by glass. And personally, I find it impossible to even imagine what our civilization would be like without all of these developments. So we have a lot to be thankful for in terms of these developments in glass science and technology. Now, when Dr. Varshnaya and I were preparing the third edition of our book here, one of the figures in the back, in chapter 23, at the back of the book, is the results of a survey where we asked a whole bunch of colleagues in the field to rank what are the top 10 glass products or processes that have had the greatest impact on humankind. And we got responses from 91 experts in the field from across the globe. And we gave each one a ranking. And basically, we ranked all of these top advances when it comes to both glass products, which are shown in blue, as well as glass processes, which are shown in red. And the most important one, as rated by these 91 experts in the field, was glass lenses. This is ophthalmic lenses for spectacles, glass lenses for microscopes and telescopes. This was followed closely by the development of optical fiber, which, as I've mentioned, was critical for bringing us into the information age, and then followed closely again by glass windows for architecture and transportation. So, it's very easy to see how critical all of these inventions have been to bring humanity to where it is today. Now, the next most important one that's listed here, that's shown in red because it's a process rather than a product, is the Pilkington float process. This is the process that was invented by Sir Alistair Pilkington at Pilkington Brothers in the UK back in the 1950s, by which flat glass is made today. So all architectural glass, all glass that's used in automobiles, it's all made via this float process where there is a bath of molten tin and the molten glass is floated on top of this bath of molten tin. The molten glass floats on top of that bath and creates a flat sheet. And this is what enables us to have really, large, good quality flat glass with good surface quality, good thickness uniformity. All of this comes from the Pilkington float process. And it's an amazing process. If you ever get a chance to see it in person, please do so. This has been transformative, especially to the architecture industry. Like if you look at houses and buildings that were built before the development of the Pilkington flow process, so let's say before around 1960 or so, you'll notice that the windows are quite a bit smaller, they're quite a bit lower quality, but more modern buildings, especially those made, say, starting the late 1960s, they have much larger windows, much better quality windows, and all of that is because of the Pilkington flow process. So the point here is that it's not just about product innovations, it's also about process innovations. And as material scientists and engineers, we need to keep in mind that development of new processes is just as important as the development of the new products themselves. Ranked after this is glass light bulb envelopes. So, artificial lighting, bringing it to the masses. The key to that was the ability to make, large scale, low cost glass envelopes that could provide a seal to protect the filament of the light bulb from the outside environment. And this is what brought artificial lighting to everyday people. So not just the ultra rich people could have artificial lighting, but everyone could have it. Then there's glass containers, and so on. So I'll let you go through this list on your own time, but it's a very long list because there have been so many ways that glass has contributed to modern civilization. And if we look across this list, there are several common themes that emerge. One is optical transparency. Optical transparency is often a desirable or even required property of glasses for many of these applications. Obviously, it's required for glass lenses and glass windows and glass light bulb envelopes, and it's usually a beneficial property for glass containers. When it comes to optical fiber, the optical transparency is the number one single most important property of the optical fiber. It needs to be as transparent as possible so that the optical signal can be transmitted over hundreds of kilometers. Now, not all glasses are optically transparent and not all applications require optical transparency. But for most of the important applications that have had the biggest impact on human society, optical transparency has been a critical part of that. Another common theme is the mechanical strength of glass, the ability of glass to be scratch resistant, to be resistant to damage that's caused by some sort of mechanical insult. Now, of course, glass still breaks, and there has been a lot of research done recently. For example, the development of Gorilla Glass that has vastly improved the strength of glass, enabling it to be used as a cover on smartphone materials. And still a lot of work that needs to be done going forward. But for any of these products, it needs to provide the resistance to mechanical damage that's necessary for that particular application. A third common theme is chemical durability, or in other words, the corrosion resistance of the glass. In many of these applications, glass is exposed to a humid environment. It's exposed to rain or acid rain, or it's being used as a container to store acids or bases. And it needs to be resistant towards interactions between the glass material and whatever is being stored in it or whatever the environment is throwing at it. So chemical durability is also critically important for a large number of these applications. And finally, from a glass compositional point of view, one of the common themes is that silicates are dominant. What we're going to learn in this course is that it is possible to make glasses out of any liquid, provided that you cool it fast enough. But we're going to focus more time than on any other family on silicate glasses because those are the ones that have been most transformative. These are the ones that are used in pretty much all of our glass lenses, optical fiber, windows, light bulb envelopes, and containers, and so on. And this is because silicate materials are low cost, they're highly abundant, they're safe, they are environmentally friendly. They make very good quality glasses. They provide the optical transparency that we need, the mechanical strength that we need, the chemical durability that we need. And there's all kinds of different additives or other components that you can add to silicate glasses to change those properties. So in this course, we'll focus more time on silicates than any other glass family. since they are the most important family of glasses, but we're also going to cover many other types of glasses, including other types of oxide glasses and non-oxide glasses. So all of that is to come. Now, while I focused most of this discussion on scientific and engineering advances in glass, it's really important also to consider the impact of glass on our culture and on our art. So this shows a photo that I took on a family vacation a few years ago in Paris. These are some of the stained glass windows at Sainte-Chapelle, which is this beautiful chapel just outside of Notre Dame Cathedral in Paris. And this has a really interesting history. It was built by King Louis IX of France back in the 13th century. King Louis IX is better known as Saint Louis or Saint Louis. Um, and he built this chapel to house the crown of thorns that Jesus wore at his crucifixion. So King Louis IX had purchased this crown of thorns from the Eastern Roman Empire, and he wanted to build this beautiful building to house it that would be worthy of this artifact. And so going inside the Sainte-Chapelle, it's like being inside this work of art. These stained glass windows are tall and beautiful, and they just completely surround you. So everywhere you look, you're just surrounded by this beautiful stained glass with all these different colors that it can take on. And glass has been known for many centuries for its beauty, and part of that is because of all the different shapes it can take on, all the different colors, its optical brilliance, its optical transparency. And here, what you're seeing is the ability of glass to take on the form to tell stories. So each one of these windows here is telling stories from different books of the Bible. And there is so much detail that can be incorporated into this because of the versatility of glass as an artistic medium. And what we can see is that, not only is it beautiful from an artistic point of view, but the engineering properties of the glass have also been critical for us to be able to take in this beauty and to see this glass almost 900 years later. And this again goes back to the mechanical strength of the glass, to the chemical corrosion resistance of the glass, to this stability of the glass over time. And all of these properties were critical in choosing glass as the medium for making these stained glass windows. And that's why we can enjoy it today, just as people many hundreds of years ago could enjoy it as well. And, so glass has been critical, not just for stained glass windows in the Christian world, but, Islamic glass goes back many, many centuries as well. And of course, glass used across other areas of art. And it has been, such an important medium from an artistic point of view, and has contributed so much to human society on the art side as well. And so even though as material scientists and engineers, we tend to think about things in terms of their atomic structure and the properties from a scientific and engineering point of view, all of these same properties also play a critical role if that material is used for art. So let's go back in history to learn about the origin of the word glass itself. So the word glass is derived from the late Latin term glacium, and this is used to refer to a lustrous or a transparent material. So this idea of the optical transparency and the optical beauty of glass, it's built into the name based on its etymology here, going back to Latin. Glass is not the only word that is used to describe glassy materials. Another word that is synonymous with glassy is vitreous. Vitreous also comes from Latin. It comes from the Latin word vitrum, which means transparent or clear. So again, going back to optical transparency. Another word that is often used to describe glass, although we'll learn later incorrectly, is amorphous. And this originates from the Greek amorph, morph meaning shape, and then this prefix a meaning not or without. So amorphous literally means without form or without shape. And this kind of goes back to the idea of glass having a disordered structure and being able to take on any shape that you wish. What we're going to learn a bit later is that amorphous solids are actually a different class of material that are distinct from glass, and we'll get into the reasons why in a couple of lectures. But what we can tell from these words are that transparency, luster or shine, and in particular its durability when exposed to the elements of nature, were some of the most important properties of glass that have been recognized by early civilizations. In fact, glazed stone beads from Egypt have been dated back to about 12,000 BC. And several of the artifacts unearthed from the tombs of the pharaohs exhibit excellent glass inlay work in a variety of colors. And as independent objects, glassware has existed for roughly 5,000 to 6,000 years. So the history of glass goes back thousands of years. And the earliest recorded glassmaking is from about 3,300 years ago in Mesopotamia. This is in modern-day Iraq. And I'm going to read you a translation of this, what is really the earliest lab notebook for how do you make glass. And I'm going to read it to you because it offers some interesting insights and an interesting perspective coming from thousands of years ago. What they said is, when you set up the foundation of the kiln to make glass, you first search in a favorable month for a propitious day, and only then you set up the foundation of the kiln. As soon as you have completely finished in the building of the kiln, and you go and place Kubu images there, no outsider or stranger should enter the building thereafter. An unclean person must not even pass in front of the images. You regularly perform libation offerings before the Kubu images. On the day when you plan to place the glass in the kiln, you make a sheep sacrifice before the Kubu images. You place juniper incense on the censer. You pour out a libation of honey and liquid butter, and then only you make a fire in the hearth of the kiln and place the glass in the kiln. This is very interesting because obviously, they didn't have complete understanding of what the actual raw materials that they were using to make glass. They knew that sometimes they would get a combination of batch materials, put it in a kiln and get good quality glass. Other times they would try to do what they thought was the same thing and end up getting something that is definitely not glass, something that has just been crystallized or poor quality. And back then they had no way to tell what was the chemistry of the material or the atomic structure of the material. But what they knew is that it was a very finicky material, that sometimes it would work and sometimes it wouldn't. And they would ascribe this to the superstitions of the day with the religion that they had and the sacrifices that they would made and all of these superstitious things that you had to do, presumably to get a good quality glass. Sheep sacrifices are no longer required to get good glass. But the interesting thing is that this is pointing back to the importance of having the right quality raw materials and the right proportions, appropriately mixing them and melting them at a suitably high temperature in order to get a complete melting of the batch materials to have a good quality homogeneous glass. And if you don't really know what you're doing with it, sometimes it would work and sometimes it doesn't. And so this is, of course, where science comes in. Moving forward in time now to the 4th century AD, this is a famous glass cup coming from Roman times. This is called the Lycurgus cup. And the interesting thing about the Lycurgus cup is that it's dichroic. It exhibits two different colors depending upon how it is illuminated. And what you'll see is on the left here, it appears to be green, and it appears to be green in reflected light due to the presence of metallic nanoparticles that are just coarse enough to reflect some of the light without eliminating the transmission, which results in a greenish appearance. These nanoparticles are embedded silver and gold nanoparticles, which of course, presumably were not put there intentionally, but were just as a result of whatever contamination that was there. But this is green in reflected light. If you look at it in transmitted light, it appears to be red. So in transmitted light, the fine nanoparticles scatter the blue end of the spectrum more effectively than the red end, and this results in red transmission. And this is due to the incorporation of nanoparticles. This is essentially nanotechnology that was developed back in the 4th century AD. And honestly, people don't, even today, don't truly understand the reason for this particular dichroic behavior. They know it somehow relates to the presence of nanoparticles, but it has not been reproduced in exactly the same way as it has been here in the Lycurgus cup to this day. So it's pretty amazing how glass technology has been well ahead of its time in some cases. Now, looking forward, that was a bit of some of the history of glass and how it brought civilization to where it is today. Now, if we were to project forward in time, I would argue that we are still just at the beginning of the technological advances that glass will be bringing to us. And one of the areas where glass has already had a profound impact is information technology, whether it's the transmission of information through optical fiber or the display of information on flat panel displays. But going forward, what we're going to see are flexible displays. So if you make the glass thin enough, it becomes flexible and it becomes foldable and can still maintain its high strength. And so we're going to see, more ultra thin, bendable, foldable displays that are built on next gen flat glass technology. We're also going to see glass as a medium for very small, high refractive index lenses to bend light in such a way that it can create these kind of projected images for an augmented reality environment. So this would provide the ability to have some additional information that is kind of superimposed on your actual vision, whether it is some helpful instructions about how to accomplish some task, or maybe you can see people's names floating above them, or maybe it's just to catch Pokemon. But glass technology is key for enabling both augmented reality as well as virtual reality. Glass is being used for memory storage. It can provide much higher density and longer term memory storage compared to traditional magnetic memory storage. The information can be stored here in 3D. It can be stored holographically in the glass. And so it can also last a much longer period of time. So glass can actually be key for next generation of memory storage. And when it comes to optical fibers, the next advance is going to be quantum communication, where there's quantumly entangled particles. This will enable perfectly secure transmission of information, and that requires a next generation of optical fiber that reduces the optical absorption even further. So glass has already played a big role in information technology, and there's much more to come. When it comes to transportation and architecture, one of the biggest trends in transportation is going to be autonomous vehicles, so self-driving cars, which eventually will be safer and more efficient compared to the cars that we drive today. And what that means is that glass is not just important for the exterior of the vehicle, it's also going to be increasingly important in the interior of the vehicle to provide more screens for display of information and entertainment and so on, because if people are not driving, then they'll be needing to do something else inside. When it comes to the exterior of the vehicles, the windshields, one of the key things that needs to be done is going to lighter weight glass. So thinner glass for thinner windshields and windows in order to improve the energy efficiency of the vehicle. So this is a way to improve the fuel economy by going to lighter weight vehicles. In the field of architecture, so obviously energy efficiency is one of the most important things for buildings. A traditional double pane window has 2 panes of glass filled with a noble gas in between to help improve the thermal insulating ability of the double pane window. The next generation is what's called a vacuum insulated glazing, where instead of having a noble gas between the 2 panes, there's literally nothing in between the new panes. So they pull a vacuum. So the only way then to transmit heat would be through radiation, since there's no gas particles in between. This creates a mechanical stress on the glass, so the long-term mechanical fatigue behavior of the glass becomes critically important. Also, another thing about next generation architectural glass is acoustic damping glass, especially in an urban environment. Um, and also new uses of glass in the design of architecture. So an example here is the Shard. This is the tallest building now in London, has a beautiful view from the top, and all of this is covered with glass. So this is fully, all the glazing here is done with glass for its beauty and also its functionality. And an example here in the lower right is at the Grand Canyon, there is a glass bridge that sticks out over the canyon. And if you're brave enough, you can walk out on it and look down and see the Grand Canyon below. Glass technology is also going to play a key role in the Internet of Things. This is bringing internet connectivity and functionality to many devices or other things in the household that haven't traditionally had that type of functionality. And glasses will be important for both displaying information as well as interacting with those devices. Glass is critically important for renewable energy. Windmills become more efficient the larger the windmill blades become, and these are made out of fiberglass reinforced composites. These blades, in order to become larger, require a stiffer and stiffer fiberglass. So a lot of work is being done right now to develop next generation fiberglass compositions to improve the Young's modulus, to enhance the stiffness of the fiberglass, which will enable larger windmills, which means more efficient windmills. And of course, wind energy is something that is, perfectly clean green energy. Another place where glass is being used is in photobioreactors. So these are glass tubes that contain algae, where in this case, the solar energy is being converted to chemical energy through photosynthesis. And glass is being used for its chemical corrosion resistance as well as its optical transparency. Glass is also being incorporated into roofing. So glass is critical for photovoltaics, whether it's kind of standalone photovoltaics, solar cells, or solar cells that are incorporated into the roofs of buildings. Glass is a key substrate material for that. And these particular solar cells are designed to look like standard roofing. So the roof of your building can be generating electricity while it just looks like normal shingles. There's also solar thermal energy. So in this case, there are glass mirrors here, parabolic glass mirrors that act to focus the sunlight on this glass tubing. And the glass tubing contains a polymer that's going to melt under the heat of the radiation from the sun. And then that is going to be that thermal energy is going to be converted into electricity. And the glass is used here both for the tubing and for the mirrors. And so the high thermal resistance of the glass, the mechanical resistance of the glass is critical for this technology. Now, it's not just about generating electricity. Glass is also a great medium for storing power. And this is John Goodenough, Nobel Prize winner, who recently passed away. He was one of the inventors of the lithium-ion battery, and he never stopped doing research. He worked all the way up till he was about 100 years old, and some of his more recent research related to the development of glasses for next generation batteries, where glasses could provide higher density storage of energy. The batteries could be cycled more times, and they would also be safer compared to existing battery technology. Glass is also going to play an increasingly important role in healthcare. I already mentioned the importance of glass packaging. An example of this is the EpiPen. If you are someone who has severe allergies, such as allergies to bee stings, you might carry around one of these EpiPens right now. And the medicine is stored inside this glass packaging, which is high strength, high corrosion resistance, so that if you get stung or have some allergic reaction, you can quickly administer the medicine to take care of that. And this has saved the lives of many thousands of people. There are new antimicrobial glasses that are being developed. These are glasses that have a layer of silver ions that have been ion exchanged into the surface of the glass. Silver is a known antimicrobial agent. It is antiviral, it is antifungal, it is antibacterial. And this can be used where there are touch screens that are shared among many individuals. For example, if you go to the hospital, you don't want to try to pick up a secondary infection at the hospital. So this is something where doctors and nurses and patients, if they're using a shared touch screen, it would immediately kill any microbes that are on those surfaces. Or maybe if it's a shared ATM screen or any other shared screen, this is something that can help prevent the spread of infections. Glasses are also being incorporated into the body. On the lower right, this shows some bioactive glasses that are being used in bone repair. These glasses help to stimulate the body's natural healing process, the regrowth of bone. They're also used in dental repair as well. And in the upper right here, these are Steve Young and Delbert Day. Delbert is a graduate from Penn State University, and Steve is a student from Missouri University of Science and Technology. And they have developed some bioactive glass fibers that are used for soft tissue repair. These are being used now among diabetic patients who have ulcers that often don't heal for months. And these can be very deep ulcers that go as deep as down to the bone. And with these bioactive glass fibers, they get packed into the wound. They stimulate the body's natural healing process. The fiber structure provides natural pathways for the body's natural regrowth process. And it also provides an antimicrobial environment to help prevent infection of the wound. And they have demonstrated that these patients could basically have these ulcers healed over the course of weeks with very little to no scarring. So it's some amazing technology that has been enabled by glass. And now the final slide of this lecture. At the end of many of these lectures, I'd like to review some of what we're calling glass greats. These are some of the great names in the history of glass science. And I want to just sort of give one slide overviews of them, starting off with Antonio Neri. Antonio Neri lived from 1576 to 1614. He was a Roman Catholic priest from Florence, Italy, and within the realm of glass science, he's famous for publishing the first book on glassmaking, L'Art of Etruria, which was published in 1612, near the end of the Renaissance period. So this translates as the art of glass. And this was a big deal because at the time, the secrets of glassmaking were tightly held secrets. The glass workers did not want other people to know how they were making it. And Antonio Neri was the first one to actually publish a book. And this book became the standard reference for glassmakers for the next 200 years. So it was a remarkable achievement. In this book, Neri disclosed many of the techniques for Venetian glassmaking. Venice had been the center for glassmaking for hundreds of years. And there were 133 chapters in this book. He guided the reader through different experiments, making different types of glass, many different colors of glass. And his love of glass really shines through. He called glass noble. He referred to it also as a fruit of the art of fire. And one of the things that I notice about people who work in glass is that they are very passionate about it. And so this passion for glass that Neri has captured, it is living on today in many of the glass scientists and engineers and artists who are pushing the field forward. So thank you so much for watching today's lecture. What we're going to do next time is go from the end of the book back to the beginning of the book and start with chapter 1, which is an overview of glass compositional families. All right, thank you very much. And if you have any questions, feel free to let me know. And I will see you next time.